This galaxy is a corpse that got old before it was born. That's not a metaphor I'm exaggerating for effect. That's actually the most honest way I can describe what astronomers just confirmed using the James Webb Space Telescope. And I want to walk you through this one carefully, because it's stranger than most shouldn't exist headlines you've seen, and the strangeness is the whole point. Normally, when I hear something that shouldn't exist yet, I think distance, impossibly far away, impossibly early. This one's different. This is a galaxy that's already dead, already still, behaving like a 10 billion year old relic, except the universe itself was barely 2 billion years old when this thing existed. For decades, the rule has been simple. Massive, quiescent galaxies are products of deep time, built from billions of years of mergers grinding orderly rotation into chaos. And that's exactly the rule this galaxy just broke. Space Daily. Let's start with the assumption everybody carries around without ever stating it out loud. Every galaxy spins, full stop. The Milky Way spins, Andromeda spins. Basically, every picture of a galaxy you've ever seen, that gorgeous pinwheel shape, comes from stars tracing neat, orderly orbits around a common center. Nearly every galaxy in the local cosmos rotates on a central axis with stars and gas tracing roughly orderly paths. So spinning isn't just common, it's basically treated as a signature of being a normal, functioning, actively forming galaxy, which means finding one that doesn't spin at all isn't a minor footnote. It's a status marker. And it's a status this particular galaxy had absolutely no business earning yet. Space Daily. Here's why astronomers even care about spin in the first place. Because I don't want to just assert spin matters and move on. I want you to actually understand the mechanism. The way a galaxy spins is a fossil record of how it was built. Orderly rotation means the stars are still moving together, still carrying the memory of the gas cloud they originally collapsed out of, like a figure skater's arm still following the shape of their original spin. Random, directionless motion, on the other hand, what's called a slow rotator, normally only shows up after a long, violent history. Repeated mergers over billions of years add and cancel angular momentum until the orderly circulation of stars breaks down into more random motion. That's the standard story for the giant elliptical galaxies sitting at the centers of galaxy clusters today. Picture it like this. Spin one plate one direction, spin another plate the opposite direction, smash them together enough times, and eventually you've just got shards moving every which way. No clean rotation left at all. That process, for real galaxies, is supposed to take a very long time. Space Daily. How long? Roughly 10 billion years and dozens of mergers by the standard playbook. That's the recipe. That's the price of admission for becoming a slow rotator. Space Daily. And that's exactly where this discovery breaks the whole picture, because the timeline just doesn't have room for the recipe. This galaxy, it's got a catalog name, XMM-RID1-2075, sitting roughly 12 billion light years away, existed only 1.8 billion years after the Big Bang, and it already shows the hallmarks of a fully matured slow rotator, a class of galaxy previously thought to require roughly 10 billion years and dozens of mergers to produce. Do the math on that for a second. 10 billion years needed, less than 2 billion years available. This isn't a galaxy that's early. This is a finished product showing up before the factory that's supposed to build it even exists yet. Space Daily. Space Daily. And here's the thing. It's not just refusing to spin. It's also already dead in the second sense that matters to astronomers. It's already stopped forming new stars entirely. Red and dead in the language astronomers use. And it contains several times as many stars as our own Milky Way, ranking it among the most massive galaxies known in the early universe. Stack those traits up: massive, mature, quiescent, meaning it stopped actively building itself, motionless in terms of orderly rotation. Every single one of those is a trait you'd expect from an old, settled, thoroughly lived-in galaxy. And none of them, not one, should belong to something from the universe's toddler years. Space Daily. So what's the explanation? And I want to be careful here, because this is exactly the point where I could either oversell a guess as a fact or tell you honestly what the evidence supports and where it stops. The team's leading hypothesis isn't the slow, grinding 10 billion year recipe. It's a shortcut, a violent one. Instead of dozens of mergers stacked across cosmic time, the idea is a single head-on collision between two galaxies rotating in opposite directions, which would cancel out their angular momentum in one violent event. Think about two spinning tops, one clockwise, one counterclockwise, slammed together dead center. The two spins don't add up, they cancel out, and what's left just tumbles randomly. That's the proposed mechanism here, except at a scale of hundreds of billions of stars. Space daily. And this isn't just a convenient story invented to patch the timeline. There's actual evidence pointing toward it. The team found excess light visible off to one side of the galaxy, consistent with debris from a recent major merger that hasn't fully settled. That's the kind of detail you'd expect to see in the aftermath of a genuine cosmic collision. A lopsided glow, leftover wreckage still drifting, not yet smoothed out into the tidy shape you'd get from a slower, gentler process. Space daily. Here's the part that actually gets me, though. The sheer compression of time this implies. If correct, a single catastrophic event produced in a few 100 million years a structure that nearby slow rotators normally take roughly 10 billion years to build. That's not evolution running a little ahead of schedule. That's evolution skipping almost the entire line, cutting straight from birth to old age through pure brute violence instead of patient accumulation. Imagine watching a human being go from infant to elderly in an afternoon, and the only explanation being some catastrophic shortcut nobody had previously considered possible. That's roughly the scale of what we're talking about here, translated into cosmic terms. Space daily. Now, I want to be honest with you about exactly how much this one discovery proves, because overselling it would be its own kind of dishonesty. 3 galaxies is not a population study. This is one strong, confirmed case, not evidence that every early galaxy behaves this way, not proof that violent mergers are the dominant path to maturity in the young universe. What it does prove concretely is a new capability. JWST can now resolve internal stellar motions in galaxies seen as they were more than 11 billion years ago, opening a window that simply did not exist before. We couldn't even ask this question properly until very recently. Now we can. And once you can ask a question you couldn't ask before, you start finding things you didn't know to look for. Space daily. Space daily. Here's where this connects to something bigger, though, because this galaxy isn't a lonely anomaly sitting off by itself. This is now a familiar shape of news from the Webb era. The telescope keeps finding objects in the early universe that look more evolved, more massive, or more structurally peculiar than current models predict. Quiescent galaxies that quenched too fast, supermassive black holes that grew too large too quickly, and now galaxies that lost their spin before they should have had time to acquire one. Separately, other Webb observations have turned up massive, mature-looking galaxies far earlier than expected. Galaxies nearly as massive as the Milky Way, appearing when the universe was only about 3% of its current age, full of old red stars nobody expected to find that early. And other Webb surveys have found something almost the opposite kind of surprise. More than 1,000 orderly Milky Way-like disk galaxies scattered through the early universe, roughly 10 times more common than astronomers had predicted, during an era when constant violent mergers were thought to make such Del Space Daily Scientific American.